Hi friends, today I will explain you the uses of mathematics in our daily life. Okay, actually we are using the mathematics but we don't know what is the practical. So I will explain you here, and at first I will explain you about the binary operation, and also I will try to explain you somewhere we also do something wrong. If you will ask to someone that about the 3 square, then everyone will say that 3 square is equal to 9, but according to the group theory that is incorrect. So here what we have written, binary operation is equal to a mapping S into S, means you have a set, and after then you are using any operation, that is operation is this, then after operating the two variables you are getting this variable, and that variable will be also belong to the same set. Means the example is, suppose I have written 2 and 2 belong to natural number, okay, and 3 belong to natural number, okay. We have just choose two elements from natural number, and after then we are using the operation negative, okay. Then 2 minus 3 is equal to minus 1. You know that minus 1 does not belong to natural number. It means that this negative does not hold for natural number. So similarly, suppose I will say 3 square, I will say 3 square. So, and I have written, suppose I have written 3 belong to prime number, suppose I have written 3 belong to prime number, and I have used multiplication is the operation. If we will operate the two variable, means 3 and 3, then after then what will you get? 3 into 3 is equal to 9, and you know that 9 does not belong to prime number. It means that if you will ask to someone 3 square and someone is calling that 3 square is equal to 9, that means that he is the wrong. The question is already wrong, because he should mention that the operation is multiplication, and this number, the number means he should also mention that about the set. Then you will say that 3 square is equal to 9. So according to this theory, so 3 square is equal to 9 does not belong to prime number. So 3 square means this operation does not hold in prime number, okay. Similarly here, so here I have written something to reduce the size of video. I will show you that the practical uses of mathematics, okay. So I will start from here. At first I will say to all the students, you know that you are using when you are writing any code in C language, C++ language, any language. So in this time you use power of something you have written, okay. You use something, suppose you are multiplying 2 into 3, then after then you are getting 6, but you have used this symbol operation, this multiplication. How the computer is working, this is the question. Why I have made this, I am delivering this lecture, because my focus is how it is working in computer. This is my focus. So I have written a code. Actually multiplication means you are adding 2 3 times. 2 into 3 means 2 plus 2 plus 2 is equal to 6. Suppose I have written here 6 into 7. It means that you will add 6 7 times. 6 plus 6 plus 6 plus 6 plus 6 plus 6, 1 2 3 4 5 6 plus 7 is equal to, then after you will get the answer. So the computer is working by this method. How? I will explain you. I have written a code here. At first I will explain. If you have something you have heard about the C language, okay, this is the header file, and after then I have written include. I am including stdio.h, that is for input and output, nothing else. There is only two things, input and output, okay. And after then I have used main function, okay, and I started, and after then I have used 4 variables, 1 2 3 4 5 variables, and all are belonging to integer, okay. Then this is the input and output file, okay. Printf, I have written something that will be come in your screen. Enter any two number. Suppose I am finding n to the power m, okay, n to the power m. Then after then I have written scanf, then percentage of d for integer, and two variables I will input any value. Suppose I am, for this lecture I have written in compiler 2 to the power 10. I am finding 2 to the power 10, but you can write any value. Okay, then I have started this loop. This loop will start for j is equal to 1, j is less than m, j plus plus. M means this, m means this, means 10 times, means this loop will work 10 times, this loop. Okay, according to this example, and according to this example n to the power m, this loop will work m times, so I have written m times. Okay, after then again the loop is there is another loop, but before I have written c is equal to 0. Then after then I have written second loop, and it will start from I is equal to 1 to n. What is n? N is this. For this example, what is n? N is 2. Means this loop will be work only for 2 times for our example. But if we write any another number, then it will work for n times. Okay. So at last I am replacing c is equal to n. Then after then at last we got the result. How it is working now? Just look. At first c is equal to 0. In compiler c is equal to 0, c is equal to 0, and according to our example 2 to the power 10, so n is equal to 2. Okay, n is equal to 2. So according to this example, then after then we have written c is equal to c plus n. After then we have written c is equal to c plus n. This will work 2 times. Okay, so c is equal to c means 0, and plus n means 2. 0 plus 2 is equal to 2. So you got 2 first. This loop will work 2 times. So and again c is equal to c plus n. Now the c value of c is equal to 2 second time. Then c is equal to c plus n, but n is equal to same 2. So 2 plus 2 is equal to 4. So at last I have written n is equal to c, means whatever we have calculated, the value will be come in n, means 4 is equal to n. Okay, n is equal to 4. Okay, now the second time this loop it has completed, but this loop will work 10 times. So we are this loop will work now the second time. J is equal to 1, now j is equal to 2. Now we have come here, c is equal to again c is equal to 0. You know that c is equal to 0, but so c is equal to c plus 4, 0, 0 plus, but n is equal to 4. By previous calculation we got 4. 0 plus 4 is equal to 4. We got 4. Okay, now this loop will work 2 times. Again we will calculate c is equal to c plus n. Okay, c is equal to c means this number will come here, plus n means n is this. 4 plus 4 is equal to 8. So we got 8. Whatever we have calculated, this value will be n is equal to c. N is equal to c. Then it means that n is equal to 8, because by the help of this loop we got c is equal to 8. Now this loop it has completed. Again j is equal to 3. Okay, so j is equal to 3, but when the j is equal to start 3, then after then again c is equal to 0, because when we will come here, once we have completed, okay, then after then we will come here, again it will come here. Loop means it is working n times. Okay, so this time again c is equal to 0. Then we have written c is equal to c plus n. C again 0 plus n, but n is equal to 8 by previous calculation. 0 plus 8 is equal to 8. Okay, and again because this loop will work 2 times according to our example, so again c is equal to 8 plus 8. C is equal to c plus n. C is 8 and n is equal to 8. 8 plus 8 is equal to 16. N is equal to 16. So we got 16. Now again j is equal to 4. Then c is equal to, but c is equal to 0. C is equal to 0 plus 16 is equal to 16. And again c is equal to c plus n. C is equal to 16, but n is equal to 16. Then we got 32 and n is equal to 32. It will work 10 times, and at last we will get c is equal to 512 plus 0 is equal to 512, because it is working 2 times, and this value will come here. C is equal to c plus n. C is equal to 512 and n is equal to 512. Okay, then we got 1024. So you know that 2 to the power 10 is equal to 1024. Okay, so we used the multiplication. Okay, I explain you what is the meaning of multiplication. Multiplication means we are adding the number 3 times here. Okay, so similarly we have explained, we have written the program, that program is summing all the numbers, but we are calculating n to the power m. Now the question is, I will explain you after some time. Suppose n is very big number, means suppose more than 128 bit, then how it will calculate, I will explain you after some time. Okay, so in this lecture I have explained you how the computer is working. Okay, now you are thinking that okay, because the students they use the power of xy, or they are using this symbol in MATLAB, 2 into 3 is equal to 6, but student also they should ask to the teacher that how the multiplication is working. This is the basic question for all students. Okay, so now the question is also, again there is another question, how this is working, plus. Someone will ask how the plus is working. Multiplication, okay, we have converted multiply to addition, but how the addition is working? Okay, now we are coming in electrical engineering. In electrical engineering there are 3 parts. Number first is the fabrication technology, and second is the cadence technology, and third is the DRC, coding technology. It is totally based on mathematical analysis, and this is totally based on tools. You have to shift the transistor. Okay, then have to make your design, means you have to shift many transistor, you have to combine the transistor to make a chip. Okay, and fabrication technology means you are working something hardware work. Okay, so if you have heard something like that, NOT gate, AND gate, something like that, arithmetical logical unit in your computer system. So so we use the NOT gate, means that transistor, we are adding the transistor, many transistor, after then we are making a chip. Okay, the arithmetical logical unit, it has also made by the help of these many transistors. So by the help of transistor we have made this half adder and full adder, if you have heard. Okay, so this is the half adder. At first we will discuss, that is the JOR gate. Okay, x operation y is equal to x y complement plus y x complement, means if you will put 0 0 0 0 here, okay, for JOR gate 0 0, then what will get? 0 0 complement is equal to 1, 0 0 complement is equal to 1 plus 1, this is y is equal to 0 and 1 complement is equal to 0. So you got totally 0 number. Okay, the next time 0 1, suppose this is 0 and this is 1. Okay, this is 0, but its complement is again 0. 1 complement is equal to 0, 0 complement is equal to 1. And next time 0 1 0, this is 0. Okay, next time you have, sorry, this is 1 and x is equal to 0, and 0 complement is equal to 1. 1 into 1 is equal to 1, and 1 plus 0 is equal to 1. So similarly 1 0 is equal to 1 for this operation, JOR operation, and 1 1 is equal to 0. Now in the computer we have used the half adder, means we have combined many transistors to make this half adder. Okay, here at first we use 0 0, then after then we got the result x operation y, and x operation y is equal to this, means we are adding 2 numbers, then we are getting the result by the help of JOR and AND gate. Okay, if you use it, then you will get the result. The computer is working, means this computer is working this. Now this is the question, this is only for single bit. Okay, suppose there are very big bit, 0 1 0 1 0 1 1 1, suppose like this. You know that 1 plus 1 is equal to 0, but carry is equal to 1. This it will not work for, it will work only for 1 bit, but it will not, it will work for if there are many bits. Okay, so this is the full adder, this is the carry. There are 3 input, number first is x, y and carry. Okay, so by the help of this is the carry. By the help of this, here we have used JOR gate, AND gate and JOR gate. By the help of this, when we are adding 1 plus 1 is equal to 0, and the carry again it will come here, and after then you will get the exact result by the help of this method. If you have heard this half adder, full adder, then you will understand that how the computer is working. My focus is every time you must ask to your teacher why. Every time, even your teacher is writing anything, x operation, why are you using multiplication operation, why you cannot use the addition operation, x plus y, just like the example f is equal to ma, why you have used f into ma, you can also write f is equal to m upon a. You must ask to your teacher why are you using this operation. So